Hello, everyone. What I want to do is go over homework 7. Yeah, admittedly, this was a bit of a long homework. Um, People did okay. I would say overly lenient in the grading. Maybe for the last exam, I won't be so lenient now that you guys are going to be able to see this solution video and whatnot. Um, but yeah, anyway, 20-year, $10,000 loan, 7%, 50 payments of X, followed by five much larger payments of 6X. Find X and fill in the amortization table. So I have it filled out in another PDF. I'll just do the calculations. Um, but yeah, so when in doubt, draw a time diagram. No harm here. So 15, whatever. 15 payments of X followed by five payments of 6X for a total of 20 years. So it's sorry, 6X. I think that's what I said. Okay, as we've done many times, so it's a 10,000, 20, yeah, $10,000 loan. So, take the present value of the X payments, XA 15, so that should be 15, 16. Um, right, plus now it's and quite a few people don't quite get this concept yet, so that's why I'm doing it. Sorry. As annuity immediate, the first payment period for the 6X's is 15 to 16. So the present value formula gives me the present value at the beginning of the first payment period, which is 15. If we treat this as an annuity immediate, if it's treated as an annuity due, then present value, the first payment period is 16 to 17, with the 6X at the beginning of the first payment period, 16. And so you discount, so it'd be 6X a double dot 5 0.07, yeah, 7%. Then you would discount it by um uh you're discounted by 16 years. But if we do it as an annuity immediate, it's discounted by 15 years. And there's no reason not to, I would say. All right, so there must have been an update with Adobe Reader's colors because it's not changing every time I change colors, which makes my life just that much easier. So thank you, everyone at Adobe. It's as if they heard my whining and complaining mentally. But anyway, 6X, a 5.07, so that, yeah, so 6X, a 5.07. Then you gotta discount this by um by 15 years. Right. Okay. Right. So yeah, and you can factor out an X. I'm gonna not gonna write it, but and this seems to get for some reason reformatted every time I do this. That is really annoying, but two Always got to do that test. Great. 1 plus 2 times 3 is 7. Okay, so yeah, factor out an x. I guess I'll just write it. It's not clear. So, oops. So this is definitely the best way to do this on a calculator. Just add these two up using the storage keys. Easy peasy. And as always, I like to do 1 over, then times 10,000. All right, so clear TVM. I'm in annuity immediate mode, 15N, 7 interest, nothing in front of the A, so 1 payment, compute present value, store it in the 1 spot. All right, so I'll just do 1 in front of the A5. You can do 6 if you want, it's up to you. Guess maybe it's a little easier to do 6. And sorry, I should not be an X there. That's an ugly looking 6. So, yeah, so let's do 6 payment, 5 and 7 interest, compute present value times 1.07 to the 15th plus recall 1. We're doing 10,000 over this, so do 1 over times 10,000 and 54,554 80. Okay, yeah, so these are the payments. So let me quickly do this. Won't do it for the next one. I'll just throw it up for you to check. Okay, so in the first year you owe 7% of 10,000. So it's 700. Okay. So let's do 55480 stored into 1 spot. So take this minus 700. 145.20 is how much should be a minus. That got erased somehow. Sorry about that. And these are all minuses. Can't see it. So minus 145. So that means it's well 10,000 minus this. So you add it up. So 10,000, 145.20. So 7% of this, 7, 10, 16. So easier to put a minus in front of here, plus 55480 minus 155.36. Yeah, again, minus. It's easier to put a minus in front of it and then add it to the previous outstanding balance. 10,000, 145.20, 10,356. Last but not least, times 7%, 721.04. So subtract 55 or take 55480, subtract your interest. So it's minus 166.24. Add it to the prior outstanding balance. 10,466.80. And of course, because you're only paying X for the first 15 years, and then you're paying 6X, which 6X is a lot more. Basically 33,2880 versus 55480. Yeah, so the payments are so low, the interest rate is sufficiently high that your payments don't even cover interest. So the interest you owe just gets thrown onto your outstanding balance. Not a good time for anybody unless you're the one making the loan. But if you're the one paying off the loan, it's a bad time. So anyway. All right, number two. So I saw a weird formula some people used. I don't remember what it was. It didn't seem to work. So yeah, I don't know what to say. It's a weird formula that gave you the wrong answer, so I don't think it's a correct formula. But if anyone wants to debate that, by all means, I'm all ears. Send me an email, and I will talk to you about it. All right, so I3 is 3%, like going back to red. I think this is really easy. It's geometric series kind of thing. Second, gotta move my microphone up. There you go. Okay. All right, so my monthly interest rate J, 0.03 over 12, and what's that? 0.0025. Right. So just like the example we did, the first payment is 1,500, then increases by 4%, then again another 4%, et cetera, et cetera. So because we start off with 1,500, payments are at the end. Payments are at the end of each month. So if T is in months, payments are 1,500, 1.04 T minus 1. So plop into your outstanding balance formula using the prospective method. So someone actually did this using the retrospective method. That is perfectly fine, but that's just takes a lot more time because you have to get the present value and add up all these payments, add up all the prior payments. It's much quicker just to do the prospective method. So it's K37, 1 plus this. V is 1 over 1 plus, V is 1 over 1.0025. So keep adding until it's the last payment. So 120 payments, 10-year loan, monthly payments. And then it's going to be 120 minus N. Right. And I would just factor out the 1,500 immediately, but that's all right. So yeah, just plop in everything. And then just factor what you can factor. I mean, there's no really other way to do this, I don't think. I mean, I forget if there was a formula out there to do this. Maybe there is. Again, my personal preference for exam FM and any kind of exam is to have as few things memorized as possible. So I'm not good at memorizing stuff. So if you're different, that's fine. Sorry, it should be squared here because it's V squared. And the last one is 1,500, 1.04 to the 1 second. Yeah, sorry, 119, 120 minus 1. 120 minus 36 is 84. Right. Yeah, and not that there's any doubts, but in case there are, just kind of skipping a step here. So this K37 is this numerator. This K38 is this numerator here, et cetera, et cetera. Whereas the V is 1 over this, V squared, divide by this, and V to the 84 is, well, this to the 84. 1 over this to the 84. Right. All right, so yeah, as an example, all you can do is factor out the first term. And if you do, it's 1 plus, you can check, 1.04 over 1.0025. Distribute, you get 37 for the 1.04, exponent of 37 for the denominator, exponent of 2. I can probably fit this. So to get an exponent of 119, it's got to be 83. Or rather, get an exponent of 84. If you have an exponent of 1 here, it's got to be 83. All right, so just simply do a geometric series formula. 1 minus, this is my R here. And like in the example, I'll do this on a calculator. I would get this and save it, make your life much easier. Kind of work backwards. It's really easy to do on a calculator if you do that. All right, so what is this here? I won't even write it, but okay, so yeah, let's do that. Not sure if yeah, okay, so let's store that in the one spot. So let's get the numerator here, raise this to the 84 plus 1 over 1 minus, recall 1 parentheses, and that's this whole thing, easy peasy. Doesn't matter what order we do things now. Let's multiply by 1500, divide by 1.0025 times 1.04 to the 36. 3,424,836,26. So I'm not going to write it down. There's no point because it's right here. But yeah, 3,424,836,26 is your answer. Right. Okay. Yeah, and again, draw a time diagram. It makes it a little easier to understand what to discount what by what. It's 0. So actually, not that it matters, but I'll make this a little bit to scale, because why not? Right. So last one, don't really need it, but so these are all okay. All right. I don't know. All right, so here 5%. And I'll do, I think I did green before. So I'll do green here. Sorry, that doesn't make any sense. I'll do one more for the payment. Was it 3% for the next 30 years? All right. So yeah, quickly do this just like the one before, 10 payments of K at 5%. So was it $150,000 loan? Let me do it in blue. KA 10 0.0, yeah, sorry, 0.05. Then do the other one. Right. So I'm not gonna write it like we did before. I guess these really should go here. Down a bit. Getting a little silly here, but yeah, so present value would be just like before. Okay, this is getting too thick. So KA at 30 of them, 0.03. And we got discounted by 10 years, 10 to 0, at 5%. All right. And just like before, do this on the calculator, factoring out the K. Actually, I think I'll just write it instead of actually redoing everything. So yeah, I guess I'll pull it out in red. I'm gonna erase it and pull it out, just factor it from everything. All right, so and yeah, you could do this as an annuity due if you really want to, discount by 11 years, but what's the point? In my opinion. All right, so 10N, 1 payment, 5 interest, compute present value. Store it in the one spot, 30 sorry, 0 TVM, 30N, 3 interest, 1 payment, compute present value. Discount by 5 years, by 10 years rather. Do 1 over 150,000. We're gonna get 7,593.13. Yeah, so I'm not gonna go through it, but if you want to take a look at the amortization table, yeah, I always been meaning to look up where the hell the term comes from, amortization. Such a weird term. I guess it's Latin. Yeah, such a weird word. But ubiquitous in accounting and finance, actuarial profession. But anyway, yeah, here's the table. The 750, 759,313 that we just got here after rounding to the nearest cent. Yeah, so you want to pause it, check. All right, so let's go back to this here. Yeah, so we want the outstanding balance after 10 years. We do not have constant payments and constant interest rates for the duration of the loan. So we're not going to use that shortcut formula. Sometimes that shortcut formula works, sometimes it doesn't when you do not have constant payments and or constant when you do not have constant payments and you do not have or you do not have constant interest rate. So we have constant payments, but we do not have a constant interest rate. So the shortcut formula sometimes does not work. I don't think I've ever figured out exactly when it does or does not work. But I would just stick to don't use it unless you have constant payments and constant interest rate. It ain't gonna go wrong if you just stick to that. All right, so OB10. And if you forget the formula, what I really like about this is, as I went through in the video, this has immediate practical meaning. After 10 years, what is the loan amount growing to? Well, everything grows by 5% for the first 10 years. So it grows to this. Well, subtract off the time value of your payments after 10 years. So the payments are the 7,593. Just so I don't have to write a lot, I'll do 13 S10.05. So it's the time value of the loan amount minus the time value of your payments. That is exactly how much you owe. That makes perfect intuitive sense, and it's easy to remember in that sense. All right. So let's get this first. This payment, 10N, 5 interest, future value. It's already minus sign, so it's good. Plus 150,000. That's 1.05 to the 10th. 148,828.65. Yeah, as I always like to say, it's sometimes a bit sobering to kind of see how little you've chipped away at your principal, or rather how much you still owe. So after 10 years, you only, even though you're a third into the, I guess it's not too bad, actually. No, actually, it's really bad. You only barely paid off, only paid off about $1,200 out of the loan. It's $150,000 loan. Yeah. But anyway, whatever. That's all right. Yeah, you really haven't touched your principal much. Okay, on the other hand, all right, so remember this is 20 years into our new loan. So it's like, yeah, I guess I'm not going to touch the time diagram, but we're looking at 10 to 20. So 20 is 10 years, 10 to 20 into kind of my new loan. And as I mentioned this a million times, this is a good way of thinking, because if you did want to refinance, you would need a literal new loan of $148,828.65. Okay. So let me even write that down. I'm putting that into quotations because maybe you aren't necessarily refinancing, but still good to think, kind of like a loan reset perspective. All right, so after 10 years, sorry, 20 years, 20 years. I don't know why I said 10. It's 10 to 30. I think in last year I had 20, but it's 10 to 30. 10 to 30 is 20 years. Yeah, one. And I'm going to use what I have in a calculator. So 1.0. Now here the interest rate is 3%. So, this is the value 20 years later of your loan amount, how much you owe after 10 years, minus your payments. Should be 20. And again, we're dealing with a 3% interest rate for the last 30 years. So, all right. So I think I've saved, yes, I thought I saved the payments. Yeah, well, it was in a time value of money key, so kind of got lucky there. All right, so let's get this here. So this is my payment, 20N, reinterest, plus 148,828. Actually, I should have saved this. I don't think I did. Whatever. All right, 64, 770, 92. Well, I'm not going to write it, but 64, yeah, this is the answer. Okay. All right, number 4. This was a little, I should have checked that the answer is a little less messy than it is, but still, I mean, it's not too bad. So I'm going to do rounding. Doesn't matter. All right, so most people, I don't think there's too many people. I know there's at least one or two, but I don't think too many people treated this as it was constant payment. It's not. It's totally different. Your principal payments are constant, but then you're chipping away at your principal, obviously. So then your interest payments get smaller and smaller and smaller. So your total payments get smaller and smaller and smaller. All right, so plop into that formula we had, KT plus 1, loan amount over number of years, plus the interest rate, 20,000, minus, I'm gonna try to not have this take too much time. So with rounding, 2133 minus 53. Okay, so immediately after the 7th year, you're gonna sell yeah, you're gonna sell the rights to the payments. So I probably should have said immediately after the 7th year's payment. I don't think I took off if you did K7 through K15, but it's understandable if you did. But yeah, I meant after the 7th payment. So we're looking at K8, K9, all the way to K15. All right. And that is 8 years because it's inclusive. So 8, 9, 10, 11, 12, 13, 14, 15. That is 15. That is 8 years. All right. So really, you could just basically copy what I did in the video. I think one person did, and that's fine. So just writing a few of these out. 21, 3333 minus 53, 33 plug in t equals 7. So what is this? 1760. And I forgot a 3 here. All right, so everything's, so each time we're decreasing by this much. So just like we did in the lecture, you basically add and subtract this number here. So that makes it 18 minus 53. So I'm adding it and subtracting it. And this next one is going to be this minus 53.33. So it's going to be same thing here, minus 53.33 times 2. I'll just do this next one. But of course, yeah, we're just subtracting off another 53.33 because now it's t equals 8. So it's 1706.66. So it's this minus 53.33 times 2. That's a bit, I can do a little better than that. Let me zoom in, make my life much easier. Yeah, that's so much better. Yeah, sorry. Okay, yeah, so we're gonna go 1, 2, all the way to 8. So people did this 18, 13, 33 here. People did this as a annuity, sorry, they did it as a constant annuity plus a decreasing annuity. It just doesn't match up if you do it that way. I don't know how to do it that way. And if you're gonna do something, just make sure it works. So I was pretty lenient there, but on an exam, I'm not gonna be as lenient because you're just kind of guessing then. 18-1. It's a little messy, but 18-1-3. Let me do it like this. Sorry, this is getting be a big waste of time. Much better. 18-3 minus. All right, so the price is present value of payments as usual. So it's this 18, 13. Excuse me. So A8 0.06. So that's the interest rate that this is priced at. Minus, I'll do it up here. So this is 1813 with the 3s continued on infinitely. So yeah, same thing with the 53.33. So I'll when I actually do the computation, I'll do 5 decimals. Why not? Sorry. So yeah, so this is an increasing. People did it as a decreasing annuity plus a decreasing annuity. And there, I don't know how you would get it to match up to something plus a decreasing annuity. It just doesn't really add up. I mean, you start it, it's just not. I mean, the problem is you're starting at 8. If it started at 1, yeah, obviously it's decreasing by 53.33 each time. but yeah, you're starting at 8. So it just doesn't really, yeah, I don't know how to get it to match up, or even if you start t equals 1, I'm not sure if you can. I think you can get it as something plus a decreasing annuity, but anyway, I think this way, sticking with increasing annuities for these problems is just much easier. So IA, and you're gonna have to plop in for the formula. All right, so what is this? So I can clear 18, 13. Oops. 18, 13. Right. So this is the payment. 8N, 6, interest, compute, present value. Uh, 41. Sorry, 42. And just a reminder, this formula is kind of annoying, but not bad on the calculator. A double dot 8.06 minus 8V to the 8th over 0.08. So make sure this is stored. It is, great. So I would get what's in the bracket first. So let's go to annuity do mode. 1 payment, 8 and 6 interest, compute present value, minus 8 times 1.06 to the minus 8. Yeah, I don't know why I have 0.08, it's 0.06. Sorry about that. That's why I got a little off. Okay, plus recall 1, 987102 is your answer. And if you round it just to near a cent here, use these numbers, you're going to be off by 7 cents. So really not off at all. All right, something similar. I probably won't actually enter it into the calculator this time. To here, you might be able to do it as something plus a decreasing annuity, but I just don't see the point. All right, you pay off 15-year, $50,000 loan, 4% constant principal. So I'm basically telling you what the constant principal is, which is kind of redundant, but it's very redundant, but that's all right. So still plop into the formula. So just like before, not that it really matters, but remember this. And here is my constant principal payments, and then the other part is the interest payments. 0.04. So this comes out a lot nicer. Again, I didn't mean to make the last one so messy. I should have double checked. And speaking of which, yeah, I don't think I did not update the hints last time. I apologize for that, even though I updated the homework. Slightly off hints. Very, very slightly, but so it's kind of weird, but it's whatever. Okay, 15,000 over 15 plus 0.04 times 15,000. 1,600 minus, well, it's 0.04, so it's like 4% of 1,000 is 40. Okay, K1 t equals 0, 1600. K2 t equals 1, 15, yeah, that's right, 1560. And we're going to do this exactly like we did before. At least that's the way I like to do it. So this is yeah, plug in 11, 1600 minus 40 times 11, you get 1160. So it's decreasing by 40 each time. So I write this as, we'll add and subtract 40. So here it's 1640 minus 80. And it's 1640, could check. So it's going to be 12 times 40. Okay, right. So here we want the accumulated value at the end of 12 years. So 1640 S12. This is being dumped into an account at 3%. All right, so it's 40 IS 0.03. And I'll just remind you what the formula is here. Not going to enter in the calculator. It's basically the same thing as we did before, but using accumulated value. This whole thing over 0.03. And you get 19 784.54. Right. All right. Last but not least, this is a pretty easy problem if you think about it, and well, or if you just went to the example video that I had before, or I had in the hints associated to this problem. All right, so pay off P times 100% of each year's interest. So we have our formula for that. So for the first 20 years, so let's see how much we have after 20 years. So just plop into the formula 1 plus my interest rate minus the interest rate times P. P for percentage here, not payment. A lot of people found a payment, which makes no sense. Because I'm saying it's P times 100% of each year's interest. That was very strange. So we don't know what P is. We'll find it in a minute. Sorry, raised to the 20th power. It's in general a T here for you want to find outstanding balance after T periods. Okay, this is going to be equal to, this is how much you owe, and you're basically paying off how much you owe by payments of 10,000 for the next 10 years. Okay. So it's 5%. And yeah, this is the present value. So in general, how much you owe is the value at that moment of the rest of your payments. That's, it's basically time valuing everything at T equals 20. So we're discounting these 10,000 payments by 10 years because, yeah. Or we're taking the present value rather of these last 10 payments, time value at T equals 20. All right, so this is the present value and payments. Again, this is like I did in the video, so get this. Then you can easily don't know if I cleared the time value money keys. 10N 5 interest compute present value 77 to 1734. Okay, so right, so what do you do? Divide by 150,000. Oops. Raise this to the 1/20. Subtract by 1.05. Divide by minus 0.05, and you will have solved for P. 1.65311 corresponds to 165% of each year's interest. P times 100%. So, all right, yeah, like I said, this is a long one, so I apologize. But I think this is the longest homework we have. So, maybe the immunization ones, by its nature, they're easy, but they're just freaking long. And there's no shortcuts, unfortunately, but it's still easy peasy stuff, even though it's long. All right, well, so long, take care. Yeah, homework 8 is up. I will grade the exams on Monday.